So, as already mentioned, our goals and what should we achieve and what are we aiming for. So this year's focus topics of Hannover Messe are digitalization and sustainability. And I want to talk today about what we at SPREAD are contributing to this and what we believe is needed to build more innovative and sustainable products of the future is bold engineering innovation. So the question is, how can we help in supporting and realizing this? And therefore, at first, a little problem context. So looking at very complex connected hardware products today, so many of the products you see around yourself here, there's an immense complexity behind. So there's up to 10,000 engineers building such a car, and they all have to align their input from electronics over hardware to software to actually make it work finally and bring it to market in a functioning way. So this is a huge challenge, and a lot of knowledge flows have to happen to actually make that really work. So bringing all of this together is a huge challenge for companies. Making that knowledge flow work is today just working with very much effort, or it's just not happening at all, and that always leads to less innovative or less sustainable products. So this is a problem, but why is this really happening? So what is the background of it? I mean, these products of what we're talking about are extremely complex, and these knowledge flows that have to happen are not easy to make, to bring between the people. So what we need to do is we have to create a system that supports them in this, to manage this complexity, because if we do, we can really untangle the overall potential of such an engineering organization. And that's something that today is, again, as we learned, very hard. And these companies always actually compromise on sustainability and innovation. 70% of their time engineers today spend by aligning and synchronizing on information. And obviously in this time, they're not looking for the best solution for more innovative and sustainable products. So that is something that we have to change. But how can we uncover this? So that is what we work for. So this is what we create a platform for. And this platform should be able to help these engineers to manage that knowledge flows and have a lot bigger knowledge footprint of every organization available to themselves at a fingertip. Because doing so will enable them to 100 times a day access some information that a colleague might know. And this is not possible by calling him, because you cannot call your colleague 100 times a day. And if you have 10,000 colleagues that you actually have a benefit from talking to, then it won't work at all, because you will just be on the phone. So this is what our system should do, and therefore we're creating apps. And as the title of the presentation says, that's what we call augmented engineering intelligence. So augmenting every engineer's intelligence with the overall intelligence of the organization. That's really what we want to do. And now looking at how do we do that? So we basically take information that is anyways available to our customers, specifically product data, 3D data and further data that describes the product. And we digitally deconstruct that product based on that data and create a knowledge network. So we call that engineering intelligence network. And this network can easily connect the different participants inside of these organizations and thereby manage these knowledge flows much better than they happen today. And by doing so, again, we create this situation where you have access to your colleagues' knowledge without actually talking to them. And that is extremely important. And by doing so, we believe we can create situations where engineers have a lot more know-how available to make better decisions and ultimately create better products. In order to show you some examples of how we do this or what we could achieve there, I would like to give you 3 examples. And one will be in R&D, so it's in the very early development phase of any product. One will be in the production phase, so when you actually have to mass produce a specific product. And one will be in the after sales phase, so in the usage phase. Let's start with R&D. Oh, sorry, there's a problem here. Yeah, so in R&D, 80% of a product's lifecycle emissions are defined in the design phase, because obviously that's when you define what this product will somewhat work like and what footprint it will have. One example, we've been working with automotive manufacturers, is the electronic wiring in a car. It's a very heavy element inside of a car, it's very complex, and it's also very expensive. So what have we done? We created a system based on our platform that uses the knowledge network to define the wiring, so the logical connection of how electronics work in a car at a very early phase, and basically define, I'm connecting a specific device with another specific device, and the system in the background always validates if what I'm doing is actually making sense, but it also optimizes the wires that you might put between these systems to an optimal length, to an optimal size, and to an optimal specification. So doing so, we can achieve that these engineers suddenly don't only do their part of a job, but they actually have access to the overall concept of a car and can define their wiring in this context. And what could we achieve by that? So as soon as we have all of this defined, we can also basically analyze for an existing product, based on the same optimization algorithms, where do you have potential to actually optimize your wiring? So, and that helped us, for example, to create such dashboards which show, okay, if I'm taking an existing car or an existing product, what can I actually optimize and weight? And that helped us for one car maker to achieve savings of 1 kilogram per car and around 10 euro per car. And 1 kilogram doesn't sound a lot, but if you produce millions of vehicles every year, that's a huge amount. And it basically comes up for one production line, for one model line of a car manufacturer, it came down to 48,000 fewer tons of CO2 per year and around 20 million in savings. So a huge impact by using the knowledge of the overall team together and really optimizing what they're doing. I will come to another example in the production phase. So what we did with the previous part is basically teaching our system how to understand electronics. Now, how can we use that in the production phase to also be better? What we do here is we basically help when correcting electric failures in a car. Electric failures are extremely complex, and it takes a lot of time to search for the right root cause. Takes today over 4 hours normally, and in workshops much longer. So what have we done really? At one of our customers, they today have now not anymore available just like a 2,000-page wiring diagram or something, but they have this available. So on a tablet, they can basically access the information about exactly the car they have in front of them. They can see where the wiring really goes, and they can also analyze where the signals flow for specific functions. And if there's a failure, we can also suggest them where to look first to actually find these root causes much quicker. That's another example. And by doing so, we can save around 1 million per production line in just simply saving search time for finding the root causes of failures. And the third example is going into after sales. So we all know the situation, something breaks down in your household, my washing machine breaks down, so what do? I have two options. I call the service agent, and I don't know what it will cost, but it'll probably cost 300 euro, or I just order a new washing machine without knowing what actually broke, which costs nearly the same. But the problem with the second option is that's not really sustainable. So how can we use the data that these engineering companies actually have when creating this product to make it available to each consumer of that product? Because using that data, we can actually give them a lot of information about the product, and they can really use it to a very good cause. And what you see here is now a little example. I've never seen this turbine here, but our system actually knows how to deal with it. It knows how it's structured, and it can also suggest when something broke, what do you actually have to replace? And it can also suggest how you can replace that, in which way. And while I might not do that myself, because I'm not the best guy in repairing something, which is true, but anyways, I could still call any freelancer who has this information available and who does it just for a fraction of the price, thereby not making it necessary to actually throw this washing machine away or this turbine away, but being able to choose spare parts that might be needed, and to also then really be able to show how this could be repaired through simple use of data that is anyways available. So what you see here now is a repair sequence in 3D animated. We can also give you an AR file of this, but this is just much more intuitive for you to understand how you could do that repair operation than anything else, than any PDF or whatever you can get. Yeah, so those were the, and oops, there's a failure there, but anyways, so a lot of advantages by that. Yeah, you connect also in this case the people that produce that machine or that know how this machine works with the people actually using it. Managing knowledge flows, that's what it's about. And now, as a summary, the benefits we could achieve, yeah, and what I think the most important point that we could achieve here is that there's a negative correlation between knowledge footprint in organizations and environmental footprint. So we have to make these organizations able to use more of their knowledge footprint which they have inside of their organizations. Yeah, and I hope this was insightful for you. And if you want to know more, please join us at our booth over there, and we can discuss how we can make this world better by using more engineering, using more engineering potential at every organization. Thank you.
Thank you very much.